In this video, we're going to look at how to use differentials to find a square root or cube root of some numbers. Now, this question says, use differential to evaluate cube root of 65. Now, we can use this format, f into x plus delta x is equal to y plus delta y or dy or dx. Now, we cannot directly find the cube root of 65, but we can find a number that is nearest to it, the cube root of that number. The number nearest to it is 64, because 64 plus 1 is 65. So because of that, our x is 64. Our change in x or the x is 1. And our y is cube root of x, and because of that we can differentiate this. If we differentiate this, we can first of all rewrite it by saying x is x raised to power 1 over x raised to power 1 over 3. That is this. So if we differentiate this by saying dy dx is equal to, if we differentiate this, we'll have 1 over 3 x minus 2 over 3. In case you don't really understand differentiation, you can watch my video on differentiation to understand what we did. Now, having done that, we can make dy subject of the formula by saying dy is equal to 1 over 3 x minus 2 over 3 dx or delta x. Now, we can say dy is equal to 1 over 3. Remember, our x is 64. We can bring it and say times 64 raised to power minus 2 over 3. Our dx is 1. Delta x is 1. So we put it 1. So we can say dy is equal to 1 over 3. The cube root of 64 is 4. So we say times 1 over 4 squared. Why is it 1 over 4 squared? According to laws of indices, cube root, this means 1 over 4 squared. 1 over the cube root of 64. So 1 over 4 squared times 1. So we have that dy is equal to 4 squared is 16. 16 times 3 will give us 48. Times 1 is still 48. 1 times 1 is 1. So we have 1 over 48. And 1 over 48 is 0.21. Now we've gotten our dy to be 0.21. We'll go back to the expression that said x plus change in x or delta x or dx is equal to y plus dy. Now we have that it is equal to, or let's write the whole expression, that f into 64, which is x, plus change in x, 1, is equal to y. Our y was, we got our y to be the cube root of x. The cube root of x, we got it to be 4. That's 4. Plus dy, our dy, we got it to be 0.2, so plus 0.21 approximately. So this is equal to this, so this will get 4.2, I beg your pardon, 4.21 if we add it. So the cube root of 65 is 4.21. Another question says, use differential to evaluate the square root of 36.1. As usual, we write out our expression x plus dx is equal to y plus dy. Now, we cannot find the square root of 36.1, but we can find the square root of the nearest number, which is 36. Because of that, our x is 36. Our change in x is 0.1. Having gotten that, our y is the square root of the 36 that we can find. So, and that is 6. So we can write out that dy dx is equal to square root of x. We differentiate square root of x. So we can rewrite it as, we can rewrite this as x raised to power 1 over 2. So if we differentiate that with respect to s, we're going to get 1 over 2 x minus 1 over 2. So dy is equal to 1 over 2. Remember, the value of our x happens to be 36. So we replace it, 36 raised to power 1 over 2 dx by making dy subject of the formula, dx. So dy is equal to 1 over 2 times the square root of 36 is 6 raised to power minus 1. Dx happens to be 0.1. So our dy is equal to, we can rewrite this as 1 over 6 times 0.1. So dy is equal to 2 times 6 is 12. So we have 0.1 over 12, which will give us 0.008. So our dy is 0.08. So from the formula that says f into x plus change in x is equal to y plus dy, we have that this is the square root of 36.1. Remember, 36.1 is equal to, our y happens to be the square root of 36, which was 6, plus our dy is 0.008, which is 0.008, and this is equal to, if you add these two, you are going to get 6.008. That is the answer. If you haven't subscribed to this channel, please click the subscribe button. Thank you.